And it says we started with 1/10 of a gram exactly of CXHYOZ, and it was burned in oxygen, and we got for our trouble this mass of carbon dioxide and this mass of water. We also know that the mass spectrum of CXHYOZ has the largest peak at 90 atomic mass units. That will become important later. To begin, now we want to look at the mass percent composition. We want to determine the mass percent composition for this compound. So if we're going to do this for carbon first, it'll be the mass of CO2, 2 moles of CO2, 2 moles of carbon, 2 mass of carbon. Okay, so now we know the amount of CO2 that we got, so we're going to start with that. 0.1953 grams of CO2. So we're going to do a mass to mole conversion. You know how to do that. 1 mole of CO2 is 44.01 grams of CO2. Okay, and now we're going to convert to moles of carbon. It's 1 mole of carbon per 1 mole of CO2. It won't always be 1-to-1, will it? Because if we were doing water, it would be 2 moles of hydrogen to 1 mole of oxygen from the formula. Then, if we want the mass, 12.01 grams of carbon to 1 mole of carbon is the mole to mass conversion factor. And here we have ultimately 0.0533 grams of carbon. Okay. Let me just say something for a moment. I'm a little bit annoyed of people coming in, sitting down, finding out I'm not taking attendance and walking out. If you plan to do that, please change your plans. If you're not going to come to class, don't come to class. I don't care. You can get it on your own. I'm happy to help those who want to come to class. You paid for it. It's yours. But I am going to be unhappy to see people walking out in the middle of class, unless you have a legit reason. If you do, stop by and say, I'm sorry, I've got a test in this other class. I need to leave a little early. That's cool. I'm okay with that. But if you're just coming to check whether I'm going to take attendance or not, don't bother. You won't be here at the end of the semester anyhow. 40 to 45% fail and drop the course, and the biggest reason is they don't come to class. Enough said? Okay. Now, let's go ahead with this. We have the mass of carbon. Let's do the water. 0.1000 grams of H2O times 1 mole of H2O divided by what? Molar mass of water, 18.02 grams. Okay? Now I want to convert to the moles of hydrogen. The formula says, hey, there's 2 moles of us hydrogen atoms for every mole of H2O. And then 1.008 grams of H per 1 mole of H. And when I did all that, I got 0.0111 grams of H. Okay? If you, well, at this point we could add these two together and subtract from 1/10 of a gram the starting amount, we get the mass of oxygen. You know that. I'll show you another way to do it shortly. Okay, let's do the calculation of the mass percent of carbon. That is 0.0111 0.0533 grams of carbon divided by 1/10 of a gram of sample, 0.000 CXHYOZ, and then times 100%, and that gave me 53.30% carbon. For hydrogen, we do the same thing. It's the mass that we found of H, 111 grams of H over 1/10 of a gram of sample times 100%. It's equal to 11.19% H. We add these two together, it's 64.49%. Since the only other thing there is oxygen, 100 minus 64.49 to the appropriate number of significant figures is 35.51% oxygen. So you can leave the oxygen to the end if you like, or you can calculate it from the mass of oxygen. Now there are several steps here, and you have to get them all right.